Okay, so today we are going to discuss the difference between CPAP and BiPAP. This question has been very frequently asked on the channel and on ICU.in forums, and this question is actually very important. There are a lot of literature, a lot of videos, lot of text available on this. Those who want to read in detail, you can always review them. But what we are going to do today is we are going to simplify the concept so that once you understand this, you will never forget. So we are dividing this video into three parts. One will be we'll understand the process, and once you understand the process, in the second part we'll review the graphs, and in the third part how you can adjust the settings so that your blood gas or according to the patient requirement you can adjust the settings on CPAP and BiPAP. So let's start with understanding the process. So before jumping into CPAP and BiPAP, you need to understand two major concepts. One is your respiratory cycle, the other is difference between oxygenation and ventilation. So your respiratory cycle consists of two phases. One is your inspiratory phase and the other one is exhalation, means expiratory phase. So two phases, inspiratory where you need to inflate the lung, and expiratory phase we need to deflate the lung. So you need to understand this thing. So a complete respiratory cycle consists of two phases. Secondly, what you want to do with the patient, whether the primary requirement is oxygenation or primary requirement is ventilation. So oxygenation means the patient is hypoxic, there is hypoxemia, you need to increase the oxygen level in the blood of a patient. And ventilation, by ventilation means CO2. Ventilation means chest is moving, chest is expanding and collapsing nicely so that your CO2 is getting properly exhaled during the respiratory cycle. So that's why whenever you see a PCO2 rising in your ABG, you say that the patient is hypoventilating, means the chest wall is not moving properly, or if it is moving at a slow rate, so that patient is hypoventilating. When PCO2 is low, you say that patient is hyperventilating. That means the CO2 is getting washed out very fast from the body. So understood? Inspiratory phase, expiratory phase, and oxygenation versus ventilation. Now what happens in CPAP? The full form is continuous positive airway pressure. That means there is a continuous positive airway pressure throughout the cycle. That means it is in inspiratory phase also and inspiratory phase. Suppose at normal pace I am breathing like this, but what will happen? CPAP, suppose if CPAP pressure of 5 mm of H2O, now my baseline pressure in the lung will be like this, and I will now ventilate above this, but this CPAP pressure will remain both in the inspiratory phase and both in the expiratory phase. What this is doing is, it is preventing the alveoli to collapse during expiration. So basically it is a positive pressure at the end of inspiration and expiration both, so that your alveoli doesn't collapse. Suppose I breathe like this and my alveoli get collapsed, but because of hypoxemia we want that there should be a pressure, minimum pressure beyond which we don't get exhale and the alveoli doesn't get collapsed. So my CPAP what will do? It will inflate the lung like this, or it will prevent the lung from deflating below this point, and then this pressure will remain both in inspiratory cycle and the expiratory cycle. So this is a continuous pressure. But suppose if this 5 mm of H2O is not able to maintain the oxygenation in the patient, we increase it to 15. So now what will happen? My baseline pressure will be like this. This is the pressure throughout the cycle, and I need to inhale and exhale above this pressure. So for inspiration it is fine. I am oxygenating, I am taking breath about this pressure. But in expiration, I need to exhale above this pressure. So there is a pressure 15 mm of H2O in the expiratory phase also. And now I want to exhale, I cannot exhale because my pressure in the lung will not go down beyond 15. So I cannot expel the CO2. So CPAP will help in increasing the PO2 in the level, but will not help in adjusting the PCO2 and may hamper the release of PCO2 in a particular patient. Now that's where BiPAP comes into play. So because we need a mechanism so that in inspiration there remains a pressure which helps at inflating the lungs, and in exhalation the pressure drops down to a certain level which doesn't allow the alveoli to collapse, but it should drop so that I can exhale properly. So that's where your BiPAP comes. In this, the pressure which remains at a constant level is called the EPAP, expiratory positive air pressure, and the pressure which increases during the inspiration is IPAP. So what happens in BiPAP? You will inhale like this. This is your IPAP, and in expiratory phase the pressure drops by the BiPAP to EPAP level, and now I can exhale properly. So in inspiration there is a increase in the pressure which helps to imbibe the oxygenation, and at the end of expiration there remains a minimum pressure which doesn't allow the lung to collapse, but it allows the lungs to get emptied. It releases the pressure. So EPAP remains at continuous pressure, and IPAP increases during inspiration and get decreased during expiration so that I can exhale. So we'll now see in the graph, and you will pick this concept. Now you see here, this is your pressure and this is your time. This is your pressure and this is your time. So you are seeing in CPAP there is a continuous positive pressure. This is a respiratory cycle, little bit variation, usually it remains straight. So a +5 is maintained during spontaneous breathing, whether it's inspiration or expiration, it is getting maintained. But what happens in EPAP, there remains a pressure, see, of 5, beyond which is keeping the alveoli open. But in IPAP it is helping to increase the pressure. It is helping to inflate the lung, and now in expiration it again drops down to a particular level, but beyond EPAP it doesn't fall down. So note, in IPAP 15 is the PSC value, pressure support value, and EPAP is the CPAP value. What they are trying to say that basically your CPAP is EPAP, means a continuous pressure which is present throughout the cycle is your CPAP value or EPAP value, or if you are ventilating on a ventilator, invasive ventilator, connected through an IV, it is the PEEP, positive and expiratory pressure at the end of expiratory cycle. So your CPAP is same, EPAP is same, and PEEP are same. All three are same. There is a minimal pressure which remains throughout the cycle, but the purpose is to maintain a minimum pressure at the end of expiration. It doesn't go beyond that. And your IPAP is basically pressure support above PEEP. You have understood that there is a mode called pressure support above PEEP ventilation. Na? Sorry, IPAP is pressure support above PEEP, then exhalation, and this PEEP or EPAP remains continuous throughout the cycle. So what this helps is, it helps to maintain oxygenation and helps to maintain the PCO2 level also. Now the important point is, it is not like that ki EPAP is for your oxygenation and IPAP is for ventilation. It is the difference between these two values which is important. Means for PCO2 to wash out, there should be movement of the chest. So IPAP should be high and EPAP should be low. IPAP should be high and EPAP should be low. So if your IPAP is 15 and EPAP is 5, the difference between 2 is 10. So fair enough difference. But if IPAP remains 15, your EPAP remains 10, then the window for the chest to expand and collapse is low. So it can happen that your PCO2 gets rise in this patient. So now you have a patient in which, now we coming to the third part, how you will adjust the settings. So if your blood gas says that patient is having PO2 of 50, pH of 7.4 and PCO2 is 35. So if PCO2 is normal, your pH is normal, only thing is hypoxemia. So what you need to do is, you need to increase the oxygenation. How will you increase the oxygenation? You will increase the EPAP so that your alveoli doesn't collapse during the expiratory phase. Alveoli should remain open and it will increase the oxygenation. Now, if there is second blood gas in which the PO2 is normal, somewhere around 80-90, but your PCO2 is 50-52 and pH is 7.2, it is respiratory acidosis, you want the chest to open and collapse, so that you want to make the chest hyperventilate or ventilate properly. So you will increase the IPAP, you will increase the difference between IPAP and EPAP. So we'll increase the IPAP to a higher level, so the difference between EPAP and IPAP increases, and then now the chest can expand and collapse in a more comfortable manner. So that's the difference between EPAP and IPAP. Your CPAP is equal to EPAP on BiPAP, which helps in increase the oxygenation, and it is also the PEEP on an ventilatory mode. So your PEEP, CPAP, EPAP are same, and they helps to increase the oxygenation. Your IPAP is pressure support above PEEP on NIV mode on ventilator, and on BiPAP it is IPAP. The greater the difference between IPAP and EPAP, the more your PCO2 levels will fall. So if you need to adjust the PCO2, increase the IPAP and increase the difference between EPAP and IPAP. And it is the difference between IPAP and EPAP which actually makes a difference in the PCO2, not the absolute values actually. So this was in nutshell about difference between CPAP and BiPAP. If you have any more questions, you can ask in the comments or preferably on ICU.in forums. Thank you. See you in next video.